I'll just push this through and I'll give you an idea of the fit. Welcome back to Workshopfriend and video number 8 of renovating my Adcock Shipley horizontal milling machine. In the last video I parted the bar to the correct length and did the prep work ready for machining this bar to the correct diameter. Now, given that it's about 27 inches long, that's quite a task for my little Myford lathe. In preparation for this, I made a homemade fixed steady, which you will have seen in use last video, but it's really going to be put to use in this video. So in preparation for machining the bar, I need to make sure that the bed is level. So I've got my engineer's level here, and I have actually picked up quite a bit of movement since last time I leveled it. So I'm just adjusting the level screws. So I just want to bring the bobble very slightly to the rear. So that means we need to lower the front. It takes a while for the bobble to settle, so it's very easy to overshoot. I think that's it. Okay, once again I've removed the head, and I'm just double checking the size of this bore. Now what's a little bit surprising is actually it's slightly over nominal 2.5 inches. It's 2.5, I'd say around about 2.503. Now, because the bar is very unwieldy and I don't really want to take it out of the machine too often, or more often than necessary, I'm going to have to make a plug gauge. So I don't know how this is going to turn up. It's an old weight, cast iron weight, and it's about the right diameter. So I'm going to turn that into a plug gauge. Really, a plug gauge should be have the right proportions, adequate length as compared with the diameter. But I'm going to try this. It's rather a lot of material to waste just to make a gauge, which is going to be sort of 3 inches long. Well, I've Loctited the shaft into the iron casting and left it overnight to cure. So what we need to do now is to turn this to the appropriate fit in here. Now it remains to be seen whether this is sufficiently deep to stop it from locking up and will really enable us to make a proper gauge. But I thought it's worth having a go. This is a handy piece of material and it's about the right size. I've machined a little step on there, which is slightly under, and that's slightly over, so we'll try that, see if it fits. Machine, you can see this is a rough old casting. It's got porosity in it, but I think that's not going to be a problem for what we're trying to do here. So if you can see, if I can catch that in the light, you should be able to see there's a little land there. This portion is turned slightly undersize, and that's left slightly over. Right, the first bit definitely goes in, but the second doesn't. So we're looking for 2.503 according to my measurement with the calipers. the outside diameter of this is 2.5035, so 3.5 thou over 2.5 inches, and this is just about 1 thou over 1/2 inch. So we don't want to go down to that step. We want to gradually reduce this until it just goes in the hole. I'm just going to line that center pop up with the emblem on here, seat it right in. Hopefully we get some fairly good repeatability. I know this chuck it's pretty good, so hopefully we can pick this up. That sort of goes in, but it's tight. Intuition tells me that if I were to make that shaft that size, the whole thing wouldn't go in. It's one thing getting 3 or 4 millimeters in, it's another thing getting a long shaft into a bore like that. So what I'm going to do is I'm going to take another 1/2 thou off that and then see if that gauge goes all the way in. So this is a plug gauge having been used a couple of times, and if you look carefully you can see a polished area there, and this area is less affected by pushing it through the bore. And sure enough, when I measure it, I can see that this is just 1/2 thou over 2.5 inches, and where it's polished it's 1 thou over 2.5 inches. But nevertheless, that goes through the bore. I'll show you, and I think that will give us a clue as to what size we should make the shaft. So I've removed the cotters, obviously, and I've just cleaned up the bore with a bit of Scotch-Brite and lubricated it both sides, and we'll just I'll just push this through and I'll give you an idea of the fit. So this is the large end first. And I've got a similar fit on the other side. Of course, it's going to be much more difficult to get a bar to go right through both sides, and that's going to be a real test of straightness. And I don't know if that's going to mean that I'm going to have to reduce the diameter slightly, but at least I've got a starting point. So we'll aim for 2.5 plus 1 thou, and then we'll see how that goes. Well, I spent about an hour and a half just setting this up so I can get the finest possible feed. I don't have a screw cutting gearbox on my Myford, so I fiddle around with the available gears I've got, and I've ended up with a 21 to 65, 20 to 70, and then a 20 to 75. So that gives me an overall gear ratio of 40.6 to 1. So together with my 8 TPI lead screw, that gives me a feed rate of just over 3 thou per rev, which I think is fine. If I need to, I can up the ratio, or I can down the ratio slightly to increase the feed if I need to. So I'm starting by centering this end of the bar in the 4-jaw chuck. And then we'll get the vertical alignment correct. Okay, that's good. So last time I used this, I set it up around about this position, and I've moved it over here, and it's maintained the vertical alignment, so that's good. And finally, we will check the horizontal alignment. Okay, I would say it's got to go that way slightly. So we'll put the top on, and then we'll start adjusting the lower two. Yep, that's centered. So we'll tighten down the fingers, make sure everything is okay. That's a bit tight. I better loosen that off a bit, I think. Interesting that the bar there is showing run out. I have no idea why that would be. It's this cast iron. Can't imagine it's bent. This doesn't seem to be a worn area. I don't think the ends are worn. So why this is running out, I don't know. Maybe that is actually a worn area. So yeah, I guess what's happened in the center here is as the table is moved up and down on the pillar drill, it's worn this, and that's why this is showing run out. You'll probably see me fiddling around with this several times during the video. This is actually the lubrication for my front bearing, and because there's quite a lot of load on that front bearing, I just want to make sure that the oil is flowing properly. Because of the limited bed length, I'm having to cut both the left hand and the right hand directions. So I'm using the other tool to cut towards the tailstock. I've divided the length up into inch increments, starting at 0, 1, 2, 3, and all the way up to 14. Didn't quite get to 15 because this is the transition between the left hand cutting tool and the right hand cutting tool, and so the surface there is not quite good enough for measuring. But I can use this length here to determine how parallel we're cutting. So between 0 and 14 we have a difference in diameter of 2.5 thou. This is in fact 2.5 thou larger than that. So what I plan doing now is to adjust the fixed steady, moving the bar over slightly until now this is where I'm very grateful now for these jacking screws, which originally I wasn't going to include, but this certainly makes setting up a lot easier. So I'm just slackening off the fingers, the lower two. I don't think I need to touch the top one at the moment. And what we'll do is we'll move this over 1 thou. So I've got this on 0 and we're looking for 1 thou movement in this direction. So just slacken this off slightly and tighten this one up. That's half a thou. That's 1 thou. So while we're at it, we'll just check for concentricity. And yeah, that looks good. There's a bit of surface roughness on there, which is picking up, but that looks concentric to me. Okay, I'm just going to clean everything up. I'm doing my best to keep the cast iron dust off the lathe bed. Give this a clean down, and then I'll regrind both these tools, ready for another cut. This time I'll take less. I've been removing about 40 thou a cut, or 40 thou pass. The last one was actually 50 thou and it was fine, no problem. Easy. I'm taking it slow. The RPM is right down, and the feed rate is 3.5 thou per revolution. And these are just simply high-speed steel tools. They're working fine, giving me a good surface finish and a good degree of consistency as well. So I'll take this over to the grinder, just give that a touch up, give them both a touch up, the left hand one and the right hand one, and then we'll be ready for another cut. Not unsurprisingly, over long periods of operation, there was some wear on the fingers which had to be taken up. So here, in preparation for reversing the direction of cut, I'm rotating the top slide and presenting the other cutting tool. Although this is presented as one video, these machining operations took place over 3 or 4 days, and some of these individual cuts took more than 1 hour 10 minutes. So I'm just going to divide up the remaining length to work on into inch segments so we can take some measurements and record those and see what adjustments we need to make. Now hopefully you can see my red crayon marks along here at 1 inch intervals, and I've measured along the length with the micrometer at each diameter at each station, and I've tabulated it. Actually quite encouraging really. So what we're looking for, according to our plug gauge, that's what we're going to work to. So that diameter is 2.501. So we're aiming for that. And so in terms of thous over 2.5 inches, that's 3 thou over, 3, 3, 3, 3, 3. And then at this point it drops down to 2.5, 2.5, 2.5, 2.5, 2.5, then back up to 3, 3, 3, and then down to 2.5, 2.5. So what that means is I need to turn this to the minimum, according to the minimum dimension, the 2.5 thou. So I need to take 1.5 thou off. Now to do that, I need to take the tool out, give it a quick regrind, and stone up the edges, set it up again with a nice shallow cut, so we've got plenty of tool cutting there to improve the surface finish, and we'll aim for 1.5 thou off at this point, and hopefully if we just let the tool follow all the way through, we'll be on dimension here and here, and just a bit over these two portions, and we'll have to find out how to reduce those diameters. I was going to put a very slight radius on the corner there. So I'm just taking a check here at the beginning of the cut. You've got to do it, I found you've got to do it with the feed engaged, because there's an ever so slight rock on the carriage, even though this is a recently refurbished machine. So with the feed on and a cut taken, I can now check, and we're looking for 2.501. There we have it. So I'm going to let this cut go all the way through, and hopefully we'll end up with 2.501 at the minimum, and just a little bit over here and here. We need a chamfer on the end of the shaft. I've just moved this out, slipped it forward a bit to get a bit of space. Hopefully the machining on this shaft is now finished. If I need to do any polishing, I can put it back in the lathe to do that. So now we've got space, I'm going to put the chamfer on there. This is more than decoration, it's to enable a smooth lead in. This is going to be a close fitting bore, so it's not going to want to go straight in. So a little bit of chamfer there will help us. The original one was about just over 1/16, so we'll add that feature. Okay, I'm going to try fitting this, and I haven't tried this yet, so this is live on camera. We'll see what happens if we can get this to fit in. Hopefully it'll be a nice fit with no free play. Hopefully it will pass through this end and the other end as well. We'll see. There we are. Okay, what I need to do now is to take the cap off the other end, put it on this end, and reverse the work in the lathe and machine this final portion. Okay, roughing out this missing portion now, which I couldn't access when it was the other way around in the setup here. The bar is reversed. I set up this end concentric in the 4-jaw chuck using the DTI, and then traversing with the saddle along the length with the clock on the top and the front face, I made adjustments with the fixed steady using the jacking screws, and that only took about 10 minutes to get that true again. Now what I'm going to do is keep an eye on the concentricity, because it's possible that after roughing out this is no longer going to be running completely concentric, but I want to pick up this diameter. So towards the end I will again clock this diameter, make any necessary final adjustments in the forge or chuck, and then finish the final cut through. So hopefully you can see there that it's less than 1/4 of a thou according to my clock. I think that's going to be close enough. I fiddled around with this for a while and I can't get any better than that. So what we're going to do now is we're going to measure this diameter, compare it with this side, and take off the difference, and that hopefully will be our final cut. Now I checked the diameter here and here, and it's parallel, so we don't have to worry about that. So the tailstock setting is correct. All we need to do is just get the right depth of cut. So that's measuring 2.502, 2.502, and here we have 2.5, just under 2.501. So we'll aim to take 1 thou off. Okay, well at last we've got this bar installed, and I thought that it would be interesting to see how much deflection we can pick up on the end here. This is 14 inches in front of this face, and this is 14 inches as well, so approximately. So without the cotters tightened, just loose there, let's just have a look at the deflection which we can pick up on the end here, the clock right on the end. So if I pull down on there with moderate force, I'm getting 2 thou of deflection downwards and a bit more upwards. I would say that was more like 3 thou upwards. And then we'll have a look at the horizontal deflection. Again, right on the edge of the bar. So that's 1.5 thou. That's 1.5 thou. Okay, let's see what happens if we tighten the cotters up. So there are 2 cotters, one at the front and the back, and basically as the 2 parts squeeze together, it pushes the bar downwards and seats it on the bottom half of the hole, and so that should take up clearance. Let's see what the result is. So for horizontal deflection, we've got 1 thou and 1 thou, and then for vertical deflection So the vertical deflection, that's about 1 thou and 1 thou. So what I conclude from that is that there is indeed a small amount of clearance in these holes, and so the cotters have pushed the bar down, and what we're picking up now, this 1 thou deflection, is actually deflection of this bar, in other words bending of this bar. And that might be surprising. 2.5 inch diameter cast iron bar, 14 inches long, whether you get that deflection. I would think that's probably reasonable. I'll do a calculation on this as a beam calculation, and we'll see if something like 150 newtons of force will give you 1 thou deflection. Sorry for mixed units there, sorry about that. But I guess really, I mean, any machine, even if it looks rigid, has a degree of flexibility in it. And if ever you've leveled a lathe, you'll know that a lathe bed which can look rigid actually does flex even under its own weight. So this perhaps isn't surprising. The question is it excessive movement? And if you get 1 thou movement here for 150 newtons, on a very light cut you might have a 1/2 thou in the middle here. On a heavy cut there would be more, obviously, but then you also have the rigidity of the arbor itself, and that's quite rigid. This is just providing extra support on the end. So it will be interesting to see when, hopefully I finish this project, how this all works out. If any of you have an original support bar like this for this type of machine, I'd be very interested to know how flexible yours is and what kind of fit it is in the head here. If you could share that with me, I'd very much appreciate it. Anyway, I do hope you've enjoyed this video and there's been something interesting for you. If you have enjoyed it, then do give me a thumbs up and consider subscribing if you've not done so already. I hope to see you next video. Thank you.